Okay, this is the last question we did, if you remember. So, looking at the next question. So, this is question number 21b. They have given you a set A, which is 1, 2, 3, and then there is a relation defined here with three elements in it 1, comma 1, 3, comma 3, 1, comma 2. The question is to add minimum number of terms so that the relation becomes an equivalence relation. Now, we know for a relation to be an equivalence relation, it has to be reflexive, symmetric, and transitive. What is reflexivity? You look at the original set 1, 2, 3. Every element of the given set should be related to itself, which means 1 should be related to 1, 2 should be related to 2, and 3 should be related to 3. So 1 comma 1 is already there and 3 comma 3 is already there. So that means I need to add an extra element 2 comma 2 into this. So then it will become reflexive. So I'm going to add a 2 comma 2 into this. What is next? The next is I should look for symmetry. There is an obvious element which is not making it into a symmetric one. That's 1, 2. What's the meaning of symmetry? If A goes to B, if 1 goes to 2, immediately it should happen the other way around as well. If A goes to B, then B should go to A. If A is related to B, then B should be related to A. So which means for it to be symmetric, responding to 1 comma 2, there should be a 2 comma 1. So I'm going to add these two elements now. So my relation will look like set 1 comma 1, 3 comma 3, 1 comma 2. Until there, it was given to us the first three elements. I added 2 comma 2 so that it became reflexive, and I added 2 comma 1 so that 1 comma 2 is going 1 comma 2 implies 2 comma 1. 1 is related to 2 implies 2 is related to 1, so it is symmetric. So this set is now relation is now reflexive and symmetric. What about transitivity? Transitivity actually already it's happening here. Example, 1 is related to 2. The same 2 is related to 2 again. So directly 1 goes to 2. Like A goes to B and then B goes to C. So directly A goes to C. 1 goes to 2, which is the first element itself. Another pair, if I take 2 goes to 2, that's like A going to B. 2 goes to 2, and then that 2 goes to 1. So directly do we have 2 goes to 1, which is that element itself. So transitivity is already there, and therefore it is an equivalence relation. Well, that's all about relations. Now we are going to talk about functions. When do we say a relation is a function? A relation will be a function if the x coordinates are not repeated. Like this is only a relation and it's not a function. So you have seen that last year. In a relation, if the x coordinates are not repeated, none of the x values should have more than one y value. Basically, x coordinate should not be repeated. Here you can see 1 is repeated twice, or rather 2 is repeated twice, and therefore it is not a function. So you know what a function is. What we are going to talk about is the two different types of functions. Okay, the first kind is called one-one function or an injective function. What is a one-one function or an injective function? For example, if you look at the two sets, A, 1, 2, it has got two elements in it, B, 1, 2, 3, 4. So I have got two sets, and I set up a relation like this. 1 goes to 2 and 2 goes to 4. So there is an element going 1 going to 2 and 2 going to 4. So this is actually a function because every element in the domain has only one image, one and only one image. X is equal to 1, y is equal to 2, x is equal to 2, y is equal to 4. So x values are not repeated. 1 doesn't have two different images. If I had also a 1 going to 3, it wouldn't have been a function. So this is a function. Now this is called a one-one function because as you see the relation in the next set, you can see that this is not 1 to 1. 1 is going to 2, also 2 is going to 2. So there are many people going to the same image on the other side. So there are many elements having the same image. So this is called many to one, while this is perfect one-to-one relationship. One has only one partner, which is 2, and now 2 cannot go and take the same partner. So 2 has to pick up someone else. So 1 goes to 2 and 2 goes to 4. This is perfect one-to-one relationship. This is called many going to the same image. So 1 goes to 2, also 2 goes to 2. So that's called many to one. So we understand what is one-to-one and many-to-one. This one-to-one function is also called injective. Next is on-to function. On-to function, when you consider this function, this is already one-to-one, but it's not on-to because it has got some extra elements in B. Or in other words, we say if B, the second set, has got some elements for which you don't have pre-images. You don't know which element is coming to 1. You don't have any element coming to 3. So there are 2 free elements here in the second set in this codomain. So if the codomain has some free elements, it's not onto. So for this set to be onto, I should erase 1 and 3. Let's see how it will look like then. So if I erase 1 and 3 from there, now every element in the second set has got a pre-image. There are no free elements in the second set. These are different ways of saying. Or I could still say the second set is called codomain. So codomain was originally 1, 2, 3, 4, while the range is the set of all answers, which is only 2 and 4. So the range was 2 and 4, codomain was 1, 2, 3, 4. They were not the same, that's why it was not onto. But when I erased 1 and 3, now the codomain is 2, 4, range is also 2, 4, so it becomes an onto function. So that's the meaning of an onto function. An onto function is also called surjective. So this is an onto function because no free elements here. Codomain and range are same. This is not onto because there is a free element 2 here. Or I can say the codomain is 1, 2, 3. Range is but only 1 and 3. So if range and codomain are not the same, it is not an onto function, or it is not surjective. Okay, so the base codomain is also called surjective. One main checking is that codomain and range must be same for a function to be surjective or an onto function. Now if there is a function which is both injective and surjective, like this case what I have shown is actually both injective and surjective, both one to one and onto, then it's called a bijective function.